Hello, today's video is going to be Introduction to Series. So in the last video, we discussed Introduction to Sequences. Well, a series is when you add those terms together. So the definition of a series is the sum of the terms in a sequence. So in these examples that we have here, it gives us a sequence of 1, 2, 3, 4. Well, when we add those together, 1 plus 2 plus 3 plus 4, we're going to get 10. Okay, so the next one, 3, 6, 9, 12, ... Well, we could add these together, but what do we do about this ... Well, that means that this sequence has no end. It goes on forever and ever and ever. And that means that as it continues, it's going to go to infinity. So it's never going to end. Then this third one is a special kind of thing. And we're going to write in here that it equals 1. But I don't really want you to worry about this one. It's a special case, and it's weird, and it's complicated, and we're not worried about it. So what we want to learn is how to calculate partial sums. And over on the left side of your paper, there's a box. It says partial sums and has a box. A sum is written as capital S sub n. And this just means the sum of n terms. So if this said, S5, that would be the sum of the first 5 terms. All right, so we have number 1. Find the partial sum for each given sequence. We want to find S sub 9. So that means the first 9 terms of the sequence. Well, the pattern here, 1, 2, 3, 4, 5, is just adding 1 each time. So our sum is going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. And that equals 45. I'm going to do number 3 with you, and then I'm going to let you do 2 and 4. So our pattern in this one is 1, 4, 9, 16, 25. Those are all perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So then our next number is going to be 36 for 6 squared. And when we add these together, we get 91. So go ahead and take a minute and do numbers 2 and 4. And now we want to talk about summation notation, which is just a way to represent a series using the Greek letter sigma to denote the sum. So this is the letter sigma, and it's really just kind of a placeholder, and all this stuff around it means different things. So the top number is the last term number. The bottom number is the first term number. And then the stuff to the right is the formula for the sequence. Because remember, the series is a sum of a sequence. So we have to be able to find the sequence in order to add it together. So find the sum of the series above. We're going to start where n equals 1. And when n equals 1, the sequence term, the term value is 2n. So our first value is 2. Then we are going to continue to n equals 5. So when n equals 2, we're going to get 4. When n equals 3, will be 2 times 3, so that's 6. When n equals 4, we have 2 times 4, which is 8. And then when n equals 5, that's the last one we're going to do, we'll get 10. And when we add those all together, we're going to get 30. So we are going to do some examples. It says expand each series and evaluate. So I'm going to show you kind of a like a long drawn out version of this. So this wants the sum, the way you would read this is the sum from 1 to 12 of n minus 1. Okay, so we want to start with n equals 1. So the first term is going to be 1 minus 1. Then the second one will be 2 minus 1. Then 3 minus 1. 4 minus 1. 5 minus 1. Plus 6 minus 1. Plus 7 minus 1. Plus 8 minus 1. Plus 9 minus 1. Plus 10 minus 1 plus 11 minus 1 plus 12 minus 1. So 12 is the last term we want to use. And when we simplify this, we're going to get 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11, which equals 66. So for number 7, we want to evaluate from k equals 1 to k equals 4 the sum of this series. So when we write this out, we're going to see that we have 5 times 1 plus 2, 5 times 2 plus 2, 5 times 3 plus 2, 5 times 4 plus 2. And that is just plugging 1 through 4 into here, and we're going to add those all together. And then as we simplify, we're going to get 7 plus 12 plus 17 plus 22, which equals 58. We are going to do one more example together, and that is the sum from 2 to 9 of 2a minus 7. Let's write that out. 2 times 2 plus minus 7. And so notice that this one starts at 2. It doesn't always start at 1. Plus 2 times 3 minus 7 plus 2 times 4 minus 7 plus 2 times 5 minus 7 plus 2 times 6 minus 7 plus 2 times 8 minus 7 plus 2 times 9 minus 7. We have gone from a equals 2 to a equals 9, and then we're going to simplify each term. So we are going to get negative 3 plus negative 1 plus 1 plus 3 plus 5 plus 7 plus 9 plus 11. And those all added together equals 32. And that is all we're going to do together. So you go ahead and finish the rest of the problems and let me know if you have any questions, and have a wonderful day.